The complaint you may be responding to may be, all of my soda drinks are sold out. Or, the water is not pouring correctly, it's short pouring. Short pouring means the dispenser will start to pour a plain water drink and it will dispense for just a couple of seconds and then stop. It will repeatedly do this over and over again. Some of the errors that you would see on the error screen may be 624, low water, low soda water. 632, no soda water. 631, no start HFCS. The first step of troubleshooting a potential FCM problem is to make sure that the back room is up to specification. Make sure your CO2 pressures are correct and your water booster is cycling properly. Make sure there are no kinks or pinches in any of the lines feeding the dispenser. Make sure the HFCS BIBs are full and oriented the correct way. Your water filters need to be checked to make sure that they're in date and that the pressure drop across them is not greater than 20 psi. If they are not in spec, then change out your water filters. Then come back out and run your tests at the dispenser. In this example, we are going to check the HFCS FCM. The first step is to open the upper and lower doors. To do this, perform the secret handshake as described in the introduction. The lower door will pop open. Manually open the upper door. First, perform a visual inspection of the tubing. Make sure that the tubing bundles feeding the nozzle are not kinked or pinched in any way. Now, log in as a technician. Then select the HFCS subsystem. One tool that you will need is a graduated cylinder, something that will hold at least 500 milliliters. You can mark the ranges that the tests are going to run, pass, fail. The target that the dispenser is going to give you for HFCS is 90, but we have a range of plus or minus 10%, so this cup is marked at 80 and 100. Anything outside of that range is a fail. We will run 3 tests on the HFCS FCM, a high flow test, a low flow test, and then a second high flow test. The reason we run 3 tests is due to the variable orifice motor in the FCM that regulates flow. These 3 tests ensure the FCM operates properly in the full open, closed, and back to open positions. We'll start the test with the high flow. You can hear the pump pumping in the cabinet. That's good to listen to make sure that the internal pump is firing. In this example, the FCM subsystem shows that it poured 89 milliliters. The target is 90 milliliters for HFCS and 400 milliliters for carbonated water and still water. The HFCS in the graduated cylinder also is 89 milliliters. So the high flow test passed. Note the amount of liquid poured into the graduated cylinder must be within plus or minus 10% of the amount reported on the FCM subsystem screen. Be sure to thoroughly clean the graduated cylinder between each check. This is especially important with HFCS. Now run the low flow test. Notice that it takes longer to perform the low flow test because the variable orifice motor is dialed all the way to its lowest position. The amount poured is exactly the same, 89 milliliters, both on the FCM subsystem and on the graduated cylinder, so the low flow test passes. Now we want to go back and run the high flow test again. Notice how much faster it is compared to the low flow. The HFCS FSM passes the third test. All of the FCMs in the dispenser operate in exactly the same way as the HFCS FCM. So, to run the test on the other FCMs, you would just select water or carb water from the dashboard. There are scenarios where an FCM would fail this test and need to be replaced. If the difference between the pour volume recorded on the HFCS subsystem and the graduated cylinder is greater than plus or minus 10, then the FCM would need to be replaced. These are the performance targets. HFCS, high flow and low flow, 81 to 99 milliliters. Water and carb water, high flow and low flow, 360 to 440 milliliters. Any measurements outside of these ranges indicates that the FCM should be replaced. If, while running the test, the FCM continues to run and will not stop as expected, or the system has to time out to stop, the FCM would need to be replaced. If the pore volume recorded on the subsystem is 0.00, the FCM would need to be replaced. If an FCM needs replacing, please refer to Chapter 2, Replacing a Flow Control Module. This chapter describes the process to replace an FCM in detail.